These are calculations regarding the solubility product constant Ksp and the solubility. To go from Ksp, the solubility product constant, to molar solubility, you must first write the molar solubility, or S, according to the mole ratio for the balanced chemical equation. This means the coefficient in front of the compound. For instance, if something is 2 carbon, then it would be 2S, and so on. Then from the solubility product constant, you would write the equation for that, and then you would substitute S for each of the compounds. For instance, if something is the concentration of 2 carbon in the instance above that I gave earlier, then you would just write 2S. Then you would solve to go get the value of S from the known value of the solubility product constant. And that is that. And for any of the problems on the molar solubility product constant equations, always write the Ksp expression and the balanced chemical equation. Now to do the opposite, going from molar solubility S to the solubility product constant Ksp, you must again write the balanced chemical equation and the molar solubility product constant. Then you have to have something similar to an ice table, where you would write the 0 for each of the products or reactants that you don't know, and then substitute it in the change with writing plus S or minus S accordingly, and then plug it in to the equation for the Ksp and simplify. Then you could get a value for Ksp. The common ion effect. When solving problems regarding the common ion effect, you have to first write a balanced chemical equation for both the common ion and the ionic compound dissolution. Here, when you write the balanced chemical equation for the common ion, use the concentration given for the whole equation, and then, kind of like the molar solubility, write it according to the mole ratios. Then write the solubility product constant equation, and then, similar to this, use an ice table, but this time you have to use the initial concentration of the common ion, and then you can assume that S is small, so you can ignore the S and only focus on the initial concentration. Then you substitute it into the equation, what you found in the ice table, and solve. And S is the molar solubility for the compound in water. Now, going on to problems about precipitation and solubility. The thing is, you might have to solve problems where you have to predict if a precipitate will form. Here you will confirm Q and K, and to see whether Q is greater than K, less than K, or equal to K, and whether a precipitate is formed. So the first thing you would do is write both reactants, write a balanced chemical equation for them. And this way you will break down all 4 compounds given to you, and also write the total volume. Here. Then you would write the balanced chemical equation for the 2 reactants separately using mole ratios and initial concentrations given. Then you would calculate the ion concentration for the final only for the insoluble products form 1. And here you would use M1, V1, M2, V2, using the total volume that you calculated before. This will give you the final concentration for the insoluble parts of the equation. Then once you have the insoluble compounds, you would put them in a balanced chemical equation, find how much of each is there, plug it into Q, and then once you have the Q value, compare it with the given Ksp or the solubility product constant. When using problems regarding selective precipitation, combine compounds with solution given in a chemical equation, balanced chemical equation. For instance, if you're given that a solution contains a certain compound, a certain cation, then you would write it knowing which cation is there from the solution and such, and reverse and basically write a new equation for each of them. Then write the Ksp, or the solubility product constant, for both of the equation. The concentration of ions from the compound is the initial concentration. So if you know the concentration of the solution being added, then you can calculate substitute that in and get the value for the final concentration of the ion from solution. And the lowest value necessary to get that final concentration would be the one that precipitates first.